I wanted to focus this part of the demo on the smart contract piece. So let's just go through to editing a smart contract. So I previously created a smart contract for this account called car demo. And this is a very simple piece of Solidity code. Basically just has three methods. So it has a method to register a car, supplying things like a VIN number, a make and model, and it also allows, you see this bundle hashed here. This is a special variable we use that allows us to off-chain data. So just by including this string, it tells the system that you're going to be able to add any number of files to this to any of these methods. So you can, within SIMBA, we use the term bundles because you can attach multiple files using multi-part form posts, and those files are basically wrapped up, stored into the backend file system, and we generate a manifest called a bundle. And that basically stores all the information about all of those files and the identifiers for those files, and then we take a hash of that particular manifest and we store that in this variable here. So the fingerprint gets stored on the blockchain, everything else is off-chained. So here, this smart contract, we can register a car, we can do an accident report, and we can do a car sale. So if we compile that smart contract, that'll tell us if there's any errors. So that goes through just the Ethereum compiler on the back end, and it will come back and say, you know, what the result of that was. So just give it a second. Okay, so here the output from the compiler. So loads of small warnings, but no errors. So that's fine. So if we click on this graph view here, what happens is that we can generate different views of that. So now we've got this Solidity smart contract. You can start with a smart contract. You could also start with this assets and transactions view. So let's take a look at that. So the asset is a car, and the transaction on the car, a car sale, registered car, and accident report. Now this screen here can be used to auto-generate the Solidity. So let's have a look at that another way. Let's look at the graph view of this. Well, this does basically a simple graph showing the relationship between the assets and each of the transactions for that particular asset. So we have a car sale, a registered car, and an accident report, which are all transactions on a car asset. Well, we can add another asset. So we could say add a transaction to a transport car. And the asset name is a car. And what parameter transport car company used to transport the parameter. So let's add a string there. Add another parameter to say date transferred, and the parameter name there is an int as a Unix timestamp. Done, and then that adds that extra transaction. So now we have 4 transactions here, and the smart contract is automatically being rewritten to include this transport car method. So we didn't have to write any Solidity code there, we just added a transaction on that asset, and it wrote the code for us. And if we go to the graph here, we can see that the car now has a transport car method added to this particular smart contract. Beneath all of these screens is a model. So if you click this tab here, it shows you the model, and it's basically, for those technical out there, this is a UML model that allows us to kind of translate between these graphical models, Solidity, and the asset and transaction core view that we can kind of store. So this is important because let's save this new modified. So this is a car demo extended smart contract, and we're going to save that in the SIMBA organization. So click save there. So that smart contract is saved. Now you notice these different assets and transactions. This is important to understand. So when we create an application from these, what's going to happen is we're going to have these assets and transactions on that application. So they're going to form part of the API for that application. So let's go ahead and do that. So we're going to add a new application, and I'm going to call this car demo extended, and I'm going to put it into the SIMBA organization. Click create. This has just been created, so let's go ahead and configure it. Well, so to configure it, there's 4 different steps. You choose your blockchain, the blockchain type and the network you want to run on it, the file system, you choose your smart contract, and then you choose the name you want to call the API. So let's go through, let's choose Ethereum here. The network type, let's choose RinkP. I've got a wallet for a RinkP, so I'm going to choose that. The file system, so this is where all your off-chain data goes. Everything that you attach to any transaction gets bundled and stored here. So we've got IPFS. So here, let's make this permission-based true. So that means that the data aspect of this is permissioned. You can define your users, you can define their roles and how they access the particular methods in your smart contract, which is basically going to be an interface to the blockchain. And then if you go through smart contract, well, we've got a couple of smart contracts here. So this car demo extended smart contract is the one I just generated. And if I go through and I call the car demo extended and go and configure that, then what happens is that'll go off and create a transaction on the Rinkeby network. It will deploy that smart contract. But to do that, I need to give it a wallet. So I'm going to unlock the wallet that I've previously stored in my browser, which is, this is my public address for that. It takes the wallet, it signs that transaction, and then sends it off to Rinkeby for deployment. So I've just deployed that onto Rinkeby, and you can see that's deploying now. Once that's deployed, we'll have a running application. So this new application we've generated, the car demo extended. Let's go and have a look to see what that looks like. You can see that we gave it this API name, car demo extended. So let's click on that and see what it did. This is the Swagger interface. You notice that that modification of that smart contract automatically generated that new model in the back end, which automatically generated this API for your application. So you can see that these other methods, like for registering a car, for selling a car, they're all included, but these new transport car methods are also included. So you can see that this is the access information remote user and API key, which allows the API to identify the user and the permissions. But then we have a car, we have a company, and we had a date transferred, which is the new method that we added to the smart contract. And this is all visible through a post and a get method for this particular smart contract. So you have a REST API to your smart contract, which interfaces directly with Rinkeby, which was all set up through this simple process through SIMBA Chain. You also have methods for searching. So each of the operations here, so this transaction method within the context of this particular smart contract that is deployed on Rinkeby, you can list and search all transactions. So you can basically list all transactions, get every single thing that's happened within the context of the smart contract and methods, or you could search any particular variable. So for any method or ID names, you can search based on the exact name of the car, whether the car contains a particular string. So the date transferred is an integer, so you can basically do a date range, find all cars that were transferred between March and April 2019. You can do things like that. So every parameter based on its type, we generate a set of search metrics that can be used. So if it's an integer, it's a range. If it's a string, it's an exact match or basically a substring match, and so forth. So it's a very flexible system that allows you to search all these transactions.